All right, welcome back everybody. Part 7 here in this single-ended KT88 amplifier build. As you've noticed, I'm taking it kind of slow and showing you what I'm doing step by step. One of the pieces of feedback that I get and why I'm doing this is a lot of people say, hey, I see schematics online and then I see pictures of what someone's built, but there's really nothing in between that to show me exactly how to go about building an amp, assembling it step by step. A lot of other people make YouTube videos and they do like a time-lapse, fast speed thing through the whole build, but you don't get the instruction blow by blow as you go. And so I don't know if anybody will end up watching all however many 10, 11, 12 episodes there are to this, but if you want to build an amp and you want to do it piece by piece and kind of get walked through it, well, here you go. So onward on part 7 here, we're going to dive in now to finishing wiring up the KT88 first, and I'm working on the 500 ohm 10 watt resistor here, and in parallel with that I've got to put this 220 volt microfarad 100 volt high quality cap. In this case I'm using a Nikon Muse, and what I'm doing is I'm going to take both of these Nikon Muses and I think I'm going to mount them here into just these two little side lugs that are unused at this point in time, and you may be able to see them down here. These are my Arcol 500 ohm resistors, and what I did was I found a nice place that would be somewhere centered here between the tubes, which will be pin number 8 as the cathodes, and we're going to have to wire this in parallel with this, and we'll just do that via wires. But I wanted to mount these down on the chassis, so I drilled out the chassis on both sides here, right here and here, and then these little resistors just happen to be that the screws that I have were just about the right size for these, but they were just a hair too small. So I just used a tap and I tapped out these resistors so that I could bring the screws through and actually use the resistor as the nut on the other side. And it worked out quite well. They're on there, and I don't think I could move them if I wanted to. So we're going to get to wiring these things up in parallel at this point. It's a pretty simple wire. It's just as simple as coming from 8 to ground through this 500 ohm resistor, and then you got to parallel that resistor with this 220 microfarad cap. Okay, and we wired up the cathode resistor. So what I'm doing here is I come off of pin 8 here. I come over to this tag point here, which is the positive of this cap. I'm also coming off of that same point with a wire here over to one side of the resistor. Okay, the other side of the resistor here is going back to the negative side of this cap here. It is also coming over here to this common ground point I had mentioned earlier. Same little exercise over here. Pin 8 to this tab to the positive, down here to one side of the resistor, cathode bias resistor. The other side here coming up, tying into the same place as the negative, the ground here, and then another black wire running over here feeding into this. Could be other ways to go about it. The reason I like doing this is then I'm mounting these capacitors up here on these tabs, and if I ever have to replace these capacitors here, any of these, they're easy to do and they're not all wrapped up in the wiring between pins and whatnot, so it makes the amp very serviceable going forward. One other thing, someone made a comment earlier on version 6 of this video, and they were pointing out that I had used a point here that's tied to the chassis for one of my star ground points, and was that an issue? And I kind of replied and said, no, it's not an issue at all, as long as you take a wire from there and bring it back over to your first ground point. In other words, you don't want the ground to travel through the chassis. You want to give it the shortest possible path, which will be this wire back over there. And then one other question I got, I thought I would address, was a question around, let me zoom out here so you can see it. The question was, hey, if momentarily when you're switching between one side of this switch to the other with the unit on, wouldn't there be a slight momentary place where you had no screen voltage and possibly destroy your tube? And the answer to that question is yes, absolutely. You should never switch this switch with the amp on. You risk damaging a tube as a result of that. So we'll put a probably a sticky on the back of this thing or something that says do not switch with unit on. So always power it off, let it kind of cool down. I mean, let the electrolytic snarl drain out, then switch it, and then power it back on. Okay, I'm now wiring up the grid stop resistors here that go into pin 5 on the KT88s. And I'm going to tie them off to a tag point, because if you'll notice, I've also got to be able to tie the grid leak resistor, which is this 220K, and I've also got to be able to tie the 2200 microfarad coupling cap too. So one thing to note about grid resistors is, let me zoom in here and you can see, okay, it's this one right here. I'm going from pin 5 here, and I'm going to use this as my tag point. But you want your grid resistor as close to the socket as you can possibly get it. These things help provide kind of harmonics suppression, noise suppression from RF getting into your highly sensitive grid feed line. So you want these as close to the tube as you can possibly get them. All right, I'm in here wiring, and I was working on some of the resistors that feed between the KT88 and like the grid resistor and the grid leak resistor here. And I came to realize that the resistor I had wired here, which is the feedback resistor, from this point and brought it over here and tied it to where this 39K ohm resistor is, it actually needs to go on the other side of that resistor. So I brought the feedback over and I tied it to this side of the resistor. I'd actually tied it on this side. I've got to tie it right here on the other side of the resistor where the plate goes. So I'm going to end up rewiring just a little bit of this. Okay, this is how I ended up rewiring this. So if you come off of pin 3 here of the KT88, which is the plate, feeds over here to a common tag point, which is also, you can see here where the blue wire coming from the plate side of the transformer is. I ended up bringing that wire down via this kind of brown and blue wire all the way down here to the bottom and tied it off. From there, I've got my 200K kind of feedback resistor that feeds over to this point. And I've now established this new point right here as kind of a common point for pin 6 of the 6M1P. So if you notice, I've tied a little wire here over to pin 6. So we've got the feedback resistor feeding there. Coming off of the positive side of this capacitor, I've got a little wire running underneath here tying off to this point. And I've also fed the 39K plate load resistor for the 6M1P over here. And I'm also going to need to connect the 0.22 microfarad capacitor coming that feeds between the 6M1P and the KT88 right here, the coupling capacitor. So I needed a point I could tie off multiple things. I could have tried to bring all these over to pin 6, but when you try to start connecting 3 different leads into one little bitty pin, tube pin socket, it gets difficult. And you can see I did the same thing on the other side. Here's the blue wire coming from the plate side of the transformer. You've got pin 3 here, the KT88. This wire here goes up to the switch, feeding down over here, same thing through the 200K ohm resistor. Got the positive side of this capacitor feeding over here through the 39K, and there again we've tied these in here together. Okay, and then finally I came from a tie point here that I had created with the 3K grid stop resistor and the 220 ohm grid leak resistor. And I basically came from there with a 0.22 microfarad 630 volt Soling cap over here to this tie point that I mentioned earlier, which basically goes directly to pin 6. And similarly, I had the same 3K and 220K tie point over here. I came with the 630 volt Soling and tied it here, which goes to pin 1. So basically, this is the coupling between the outputs here of the 6M1P. It sends the signal over kind of follows through this capacitor, goes through this 3K into the grid to actually drive the KT88. Does the same thing on this other side. Just a little food for thought here. So, when the 6M1P here, which is your driver tube, keep in mind it takes the signal from the input of your amplifier and amplifies it some. But it's still not at a level to drive the speakers in your system. So what you have to do is you basically have to take the signal off of the plate of the 6M1P, and you have to take it and send it over and send it into the KT88, into the grid, which drives the larger power amplifier tube, which then produces enough signal, goes through your transformer, ultimately drives your speakers. But what you can't do is directly couple the output here. The reason being, the plates on this 6M1P will have a couple hundred volts sitting on it, and what you can't do is put a few hundred volts onto the grid of the next tube. So we use something here called a coupling capacitor, and what it does is it allows AC, in other words your audio signal, to flow through it, but it blocks all DC. So the several hundred volts of DC sitting right here would not go through this capacitor. Instead, you would have a much smaller voltage sitting over here on the grids of the KT88. And so a lot of people get all wrapped up around the quality of the coupling caps, and do they change the tonal aspects of your amplifier or not. And I can tell you that I've played around with them enough to know that different coupling caps will color and tone your amplifier differently. So along with rolling tubes and amplifiers, sometimes I like to roll coupling caps. May not be as big of a noticeable difference as people led to believe, but it is noticeable enough, and I just thought I would point that out to you. All right, we're going to have to take a few minute break away from the bench here to get into a little bit of biasing this tube before we go and wire it up, and you'll see why here in a minute. In essence here, we're trying to establish between the cathode of this tube and ground here somewhat of a constant voltage source. In other words, we're going to use the forward voltage drop of an LED. And these things vary greatly on LEDs. You can get LEDs that have forward voltage drop of 0.5 volts all the way up to 3 and 4 volts as their forward voltage drop. But what that does is it establishes a constant voltage here on the cathode. And the reason you want to do that is that establishes your bias as in reference to your grid. The bias of a tube is always measured its grid compared to cathode, and typically your cathode will have a higher voltage on it than your grid. Thus, you'll end up, if you measure grid to cathode, you'll have kind of a negative voltage on your grid with respect to the cathode. And so that's what we're trying to establish here. If you go read all the detailed notes that Keger had and many others had put together in this DIY audio forum, which I will try to link down below, what they're trying to say here is we're trying to establish an anode current, otherwise known as the cathode current. So for all intents and purposes, when we talk about tubes here from a practical standpoint, plate current and cathode current are always going to be the same. There is a little bit that trickles in via the grid, but it's negligible. So if we were trying to measure the plate current of this tube, we could put a voltmeter across this 39K ohm resistor, and we could use Ohm's law to say I is equal to V over R. So the voltage across it divided by the resistance would tell you the current flowing through it. You could do the same down here on this 180 ohm. But what we're trying to establish is about 5 milliamps of current flowing through that tube. That seems to be the sweet spot that the people kind of tweaking on this amp for a while had kind of found. So to get 5 milliamps, what they found is you need a forward voltage drop of somewhere around 1.4 to 1.5 volts, and you may have to play around somewhere between 160 and 180 ohm cathode resistor here. So you could either play with the LED a little bit or play with this resistor a little bit, but either way you're going to want to establish about 5 milliamps of current flowing through this tube. at the end of the day. Now, way back in the day, they would have used a battery right here to have actually set this bias, but that's not practical because batteries die, and the day you install them, they have more voltage on them than they do 2 weeks later, than they do a month later. So while it was what they had back in the day, it's just not used much anymore. A very common thing to see here is a resistor. But then you have to bypass that resistor with a capacitor because the DC and AC resistance of this resistor are about equal, and it just doesn't play out well for your AC signal. So you typically put a capacitor across that to kind of bypass the AC to ground, which ultimately affects the sound of the signal in some ways. And so, you know, this is a more advanced technique, you might call it, than your traditional resistor and cathode resistor and bypass capacitor. So, you know, some other ideas people might have had over time was to use a zener here. You see zeners used a lot to establish screen voltages, but you don't see them used to establish cathode voltages. The reason being, zeners are kind of noisy devices. They're also susceptible to some thermal drift, which is not a good thing when you're working inside of an environment that you're intentionally heating up. Vacuum tubes get pretty warm. By nature, LEDs are very low noise devices. They are also very low impedance devices. Some of these things could be as low as an ohm or so of resistance, and so that's really good for your signal. And you may wonder, well, why don't I see LEDs being used over here on the KT88 instead? Over here we've got, what do we got? A resistor and a bypass capacitor. Well, the reason you don't see them over here, LEDs max out at around 20 milliamps of current, and we'll be running more like 70 to 75 milliamps of current most likely over here on this. So you would burn up any type of LED that you would try to put in on this side. So now that I've said all that, sorry for the break away from the bench, but I just thought it was important to help you understand. The reason being, we've got to go test some LEDs now. Even within a bag, let's say you bought a bag of 100 LEDs, you might find variances within that bag. You might find some at 1.38 volts, one at 1.52, but you're trying to find one around 1.4 to 1.5, so you're trying to find something in there. You may have to test a bunch of them to actually get what you're looking for. So, and also, don't forget, there's two tubes here, right? So you've got, it only shows one here in this picture, but in reality, you've got the left channel and the right channel all within the same glass bottle, right? You're going to want to match two LEDs. You're not going to want your right channel to have 1.45 forward voltage drop there and your left channel to be 1.41. It would definitely change the signal level on each side of the amplifier. So you want to match two of these as close as you can get them. So if you buy some LEDs, get you a pack of 20, 40, 50, 100, whatever. They're pretty cheap, so won't break the bank. All right, sorry about this, but let's get back over on the bench now. All right, here we go. So what I've got wired up here, and you can't see all of it, but I can explain it to you. This is just a set of leads that I'm bringing down from a 30 volt power supply that I have up here on the bench. And what I've done is I've fed it down. And on the positive side of this, what I'm doing is I'm running it into this lead that comes over here and connects into this meter. And I've got this meter set up in current reading mode. So if you notice, I'm going into the to the amp side, and I've got it set on 20 milliamps. And so then I'm coming out the other side of that, and I'm basically coming over here and feeding it into this positive side of what I've built here. And then the negative side clips here. And so all I have then is kind of a 1K ohm resistor here coming across to kind of limit current going into this to this LED. Then I've got an LED, and then I flow back out and feed back up to the power supply. So you could use something as simple as a power supply or a battery or whatever, just to power this LED. Then the other thing I've got is I've got another set of leads connected right here that go over to this meter, and all I'm doing is measuring the voltage across this LED. So the reason I've wired up an ammeter in series with this LED and then this meter in parallel with this LED is I want to be able to adjust the current flowing through this LED to be right at 5 milliamps, okay? And then I want to measure the voltage at 5 milliamps. You could drop 12 volts across this LED with this 1K resistor. Actually, right now I'm sitting at 7 volts. So if I could crank that on up, and I start getting a lot more current through it, and it changes my voltage over here. So since we're trying to match this specifically to running 5 milliamps through it in this amplifier, I want to try to match my forward voltage drop at about 5 milliamps, and that's about as close as I'm going to get. This thing's touchy. All right, somewhere along in here. Anyway, you can see I've got about 1.9 volts of forward voltage drop being measured across this LED. And if you'll remember back on our schematic, we're looking for 1.4 to 1.5 volts here. So that's probably not the right LED for it. And these are just some random LEDs I've had laying around in my junk box. And so if we plug this one in, we notice we probably need to adjust the current just a little bit. Okay, 1.84, so getting closer, but not exactly there yet. Okay, this one, let's see what we get with it. Oh, it would help if I would forward bias it properly. All right, let's crank that one down a little bit. If you'll notice this one, which is an infrared LED that I picked up along the way somewhere, it's way down at 1.1 volts, which is a little low. And then we've got another LED here, and we'll crank that one way up. You'll notice at 5 milliamps here on this one, way up in almost 3 volts, so that would not be a good choice at all for what we're trying to do. I can tell you this right here. Woohoo. Let's crank this one down. That's about it. All right. This one running right at 1.578. And what this little LED is right here, I mean, it's a teeny little thing. I've got a whole bag of them here. You can kind of see them. This is the HLMP 6000, which is a really small kind of micro device. But I can tell you that these are really popular in the kind of DIY tube biasing realm out there. I see these used a lot. Matter of fact, if you'll notice here, I've got bottlehead written on them. If you build any of the newer bottlehead preamps or phono amps, this is what they will use to bias the 6DJ8s in the bottlehead units. So I'm probably going to roll with this one. I'm right at 1.5 volt, maybe just a little hair over. I can ultimately end up adjusting that resistor just a little bit. And by the way, I haven't sat here and gone through a whole bag of these to try to find one that might be a little lower and then to find one that's going to match it. So I'm going to do that. I won't show you that whole process, but you kind of get the gist of what I'm up to here. And look, this is a little bit more of an art than it is a science. You know, if you dropped in one that was at 1.6 volts, you may or may not even notice the difference there. So anything in this 1.5 volt range here should get you pretty close. And like I say, you can always roll a little bit with the resistor there to get it exactly at the current you're wanting to bias the tube at. So, all right, now that we've done that, I'm going to pick out a couple of these, and then we're going to jump back over and finish wiring up this amp. Okay, I made a decision here. So I've got to do something here on this front end. I've got to tie this 3K grid resistor here, grid stopper, over to a point that also a 1 meg ties to, which also goes to ground there, right? So what I'm going to do is I'm going to take on each side of this lug right here and this lug right here, and I'm actually going to run wires from them back over here and establish them as ground points. That way I kind of have a ground on this side of the tube, a ground on this side of the tube, because I'm also going to need a place to ground my RCA input cable as it comes over here. So as I feed from the back of the amp, let me zoom out so you can see, as I feed from the back of the amp here on these jacks and come all the way over to the front, I'm going to want to have a place to be able to ground those off to as well. So I'm going to go ahead and establish both of these as ground points independently from each other, both like this, tied with black wires back. I could just come from here and tie over here, would be another way I could go about doing that. Okay, I went ahead and ran from this center lug here a ground wire up and over and here. Same thing, I ran one up over and tied them off here and put some heat shrink tubing across them right here. The reason I did that is I didn't want to tie these back off here to this this secondary star point that I had created here. The reason being, the cathodes of the KT88s coming through the cathode resistor end up coming to this point right here for both of these tubes. And so the return path for current would have much larger ground currents flowing coming from these KT88s. And I didn't want that interfering with any of the return paths here for the small signal tube. So I'm kind of keeping that somewhat separate. Okay, what I've done here is I've tied my 180 ohm resistor here in series here with the little LED, and I'm going to use this to connect between the tube socket pins and a touch point over here. But I used some heat shrink tubing on them, but I left enough open on the end over here that I could actually see the LED lit up inside, and this just kind of secures it together. These leads on these little LEDs are pretty small here, is the reason I went this route. And as you can see, between the ground points here now, I have the cathode resistor as well as the LEDs wired in series here. Okay, I've now taken the 3K grid stopper over to a point, and I've taken a 1 meg over to ground. So you can see the 3K grid stopper coming off the tubes over to this point, same here coming off of pin 2, coming over to a common point, and then I've kind of gone between there and my ground point here with some Vichy 1 megs. Unfortunately, these resistors that I like here, they don't carry 1 meg in size, so I had a couple Dell Vichys that I'm using there instead. So with that being said, I can now mark off my list everything here except for the audio pod at this point and kind of the cables going to the RCA input. I think I'm going to save that for part 8 just to keep this video length in check. So in part 8 we'll wire up this potentiometer, and we'll talk about how to get it right so that your volume when you turn it to the right goes up, when you turn it to the left goes down, and how to wire these input jacks back here, and how to properly ground those over in here and not back here. We'll go through that in the next one, and we'll do a walkthrough, one end to the other, double check everything, make sure we haven't wired anything up wrongly, we don't have something touching something that shouldn't be, things of that nature. So stay tuned for part 8, and at the end of part 8 we should be there at the point we can fire this amp up and actually start listening to it and checking it out on the bench. So, okay, I think I mentioned before I dropped off of here I would take you back to the HLMP-6000. If you'll notice here, the standard red which we were using, your 50 milliamps is kind of your peak current on this thing. So we're running it at 5 milliamps. We're fine, even though that thing looks teeny. It can handle what we're putting through it. And then if you scroll down to the next page, you'll notice it says here kind of for the 6000 that a typical forward voltage VF here would be about 1.6, and they show that that's at, if you're running it at 10 milliamps. We're running it slightly lower than that, so we're somewhere around this 1.5 mark right in here. So all in all, I think that's a great choice. I'll update the BOM for this, and we'll see how it sounds. I may do some LED rolling as part of the testing on this as well. So thanks for watching, everybody. Stay tuned, and we'll be back around with part 8 probably next weekend.